Today we're going to talk about the graphs of sine and cosine. And if you recall, when I introduced the unit circle to you, I showed you this circular running track that ended up being the unit circle. And you were running counterclockwise around the circle. And Desmos was tracking your y coordinate, and it graphed that wavy shape for the sine function. So we're going to see where that shape comes from just by plotting some points. So we're going to graph y equals sine x, treating x like the angle theta as we travel around the unit circle counterclockwise. All right, so I'm just gonna plot kind of the big quadrantal angles here. Let's see, so when x is equal to 0 or the theta is equal to 0, I'm over here at this terminal point 1 comma 0. Sine is the y coordinate. So at x equals 0, I'm gonna plot y equals 0. Okay, by the time I get up to pi over 2, my pi over 2 tick mark, I'm up here where sine is equal to 1. So I'm going to plot pi over 2, comma 1. Keep going counterclockwise. Pi is over here on the left. Sine of pi is equal to 0. And then when I get down to the bottom of the unit circle, sine of 3 pi over 2 is going to be negative 1. So I'm going to do 3 pi over 2 comma negative 1. And then, let's see, 2 pi, I'm back where I started, right, at the beginning, and sine is equal to 0 again. All right. And a lot of times this is as far as we plot, because we recognize that as I keep traveling around the unit circle again and again and again, I can go to 2 pi, I can go to 4 pi, I can go to 6 pi, I can even go to negative 2 pi around that unit circle, and I'm going to get the same pattern repeated over and over again. Okay, so we know this looks like a wave, so I'm going to go ahead and fill that in. We don't want to connect the dots with straight lines. We know that the sine function is this nice wavy graph. All right, now we've got a little bumpy there in the middle. All right, so that's our basic shape of the sine graph. It starts off at the origin, heads up, and then down and back, and then it starts repeating that pattern over again. So we know that this is going to go on forever and ever in both directions. All right, let's do the same thing for cosine. All right, so now we're going to be graphing y equals cosine x. It's going to look a lot the same, except now when I circle those terminal points, we're going to be looking at their x coordinates. All right, so when I'm at x equals 0 or theta equals 0, we're going to be here where cosine is equal to 1. So at x equals 0, we plot a 1 y coordinate. Moving on to pi over 2, the y coordinate, the x coordinate is equal to 0. And then we move on to pi. Cosine of pi is equal to negative 1. So at pi comma negative 1. And then 3 pi over 2, we're down at the bottom of the unit circle. Cosine of 3 pi over 2 is 0. And then we're back to 2 pi. Again, back to where we started. A cosine of 2 pi is 1. All right, so we're going to fill in that wave shape. It's going to be the same shape, but cosine, instead of starting out at the origin, it starts off at that maximum point and then heads down from there. I'm going to start off at the maximum and head down. All right, so those are our basic shapes of sine and cosine. Let's get some terminology to go along with these graphs. All right, so here's our graphs of sine and cosine, and we want to define some new terminology we need when we're talking about wavy graphs like this. All right, so first off, we're going to talk about the midline of the function. All right, so this is the horizontal spot that's kind of the middle of the graph, and right now the x-axis is playing this role. So we would say that the midline for both of these is the line y equals 0. Okay, so that's just kind of the horizontal middle of the graph. Okay, we know that we can move that around by adding or subtracting using our transformation rules. That's what we're going to look at in the next video. The next term we want is the amplitude. The amplitude of the graph is from the midline to a peak or from the midline to a trough. Okay, so the amplitude is going to be from the midline to a high spot, or over here at 3 pi over 2 from the midline down to that trough. Either way, on the graph of sine and cosine, this is a distance of 1. So we would say that the amplitude is equal to 1. Same thing for cosine, from a peak to the midline or from the midline to a trough. The amplitude is equal to 1. Right, so the last thing we want to talk about is the period of the function. This is how long it takes the graph to repeat that full cycle, right? So sine starts off at the origin, it goes up, it goes down, and then it ends back up at 2 pi, and that's where it would start repeating that same pattern over and over again. So for sine and cosine both, this distance is equal to 2 pi. So from 2 pi, we say that the period is equal to 2 pi. And same thing for cosine, from 0 to 2 pi. All right. So period also changes when you start messing with the formula a little bit. That's what we're going to look at again in the next video.